Hello everyone, Assalamu alaikum. I am Mohammed Rezwanur Rahman Jahin. I am from Bangladesh. I study at Bangladesh University of Engineering and Technology. Me and my team have worked on a learning-based approach to fix SQL injection vulnerability in source code, and we call this tool SQLIFIX. SQL injection is one of the oldest, most prevalent, and most dangerous web application vulnerability, and it is listed as the number one threat of web application security in OSAP Top 10 2017 document. And in August 2014, a whole security found that SQL can be used to disclose confidential information of almost 420,000 websites. And SQL injection was behind stealing the personal details of around 157,000 customers of a British telecommunication company in 2015. In very recent times, 2020, an SQL attack was used to access information from survey of Link, a setup founded on Stanford campus. So our problem is basically to solve SQL injection vulnerability, and the reason behind this is that there are some programmers who make mistakes, and they use the user embedded inputs directly in the query, and for that reason the security is compromised. And for big projects there are thousands of queries, and it is very tedious and quite impossible to refactor if there are any vulnerable queries are present. So manually doing that is very time consuming, and it is a tedious work, and there is always chances of making mistakes again. Overlooking some vulnerable queries is very common, and attackers can deploy that vulnerability to gain access of the database and modify the information. Here we have shown a simple problem. We can see that it's a very simple query, but it can be modified, because if we use the user ID directly, then the attacker can insert anything, and the injected query will be executed without, if we do not make changes to the query. So we have basically replaced the simple query with prepared statements, so that the user input that can be inserted into the user ID is not executed. Here we can see that there are a lot of problems that can cause SQL injection, some such as the error-based SQLI. The attacker can get information from the error message, and they can deploy that. They can use the information. And another one is the second order SQL injection vulnerability, that one query is used, and the information that is gained from that is used in another query. This type of queries are very problematic, and they are not straightforward. That's why the attack it is not very common to solve using rule-based approaches. That's why we went for a machine learning based approach, where we learn from the past data and we try to solve the upcoming problems. And we also know that PHP is a very prominent language, and it is a very common, and it's a very easier one. That's why there are a lot of programmers who may not have academic background, and they might not be familiar with the SQL injection pattern or this problem, and that's why they might ignore that. And this can be a problem. That's why we have also tried to make a tool for PHP, and our approach is totally language agnostic, and this can be used for any basically for any language that can be parsed. And there is always a parser for every language, such as we have used the Java parser and PHP parser. There are some automated program preparing tools such as JenProg, GetAfix, Codeit, but these are very generic approaches, and we wanted something that works for some specifically for SQL injection vulnerability removal. And there are actually some automatic fixes for SQL injection vulnerability, but they are rule based, and there are a lot of dependencies such as style dependency. They are not language agnostic because they are rule based, and it is totally dependent on the language, the pattern of the language, and they work only for the common problems, such as they do not work for the second order SQL injection that we showed earlier. And whereas the automated programming APIs such as GetAfix, they are very generic, and so we wanted to work such that it will learn from the past data, such as GetAfix and other automated program preparing does. At the same time, we wanted to make it very specific to SQL injection, and that is called SQLIFix that we have generated. Here is our methodology. First of all, we collected data. We mined GitHub projects. After that, we filtered the projects so that only the projects that contains SQL queries are present. And then we separated the SQL query containing functions. And basically, we work on the functions only. We refactored the function so that the vulnerable portions are replaced with the solution. And to do that, we had to manually create fixes for the training data. Then we used a tree differencer to find the difference between the vulnerable portion and the solution of that. So we got the function vulnerable one and the solution, and we use tree differencer to see only the lines or segment of code that are different in these two portions. After that, we parsed the code and the query of that difference, and we generated AST. We then used complete this clustering to cluster the AST, and we used nearest neighbor chaining algorithm to make it faster and efficient. After all this, the clustering, and we achieve a dendrogram, and we use this dendrogram in the fixing process. For the fixing process, we use spot bugs to find the vulnerable query. Then we created AST for the query and the relevant lines. We use language specific parser to do that, and this is the input that we actually want to generate solution for, and we are going to use the dendrogram to find the solution. Here are some tools that we have used, such as the Gumtree. As you said, we use that to find the difference between the codes, and we use language specific parser such as Java parser, PHP parser. Then we use general SQL parser to parse the query, the raw query that is present in the code, and we use anti-unification to merge the AST. As we wanted to generate a cluster, so we had to merge the before codes to make a tree. Here is the dendrogram that we use to find solutions for. Here in the dendrogram, the root at the top is the most generalized AST, and at the very bottom, the leaves are the concrete AST pattern. And for our purpose, we want it as less generic as possible, because when it is generalized, it contains it contains less information, and we want more information. That's why we do not like generalized AST. We want some concrete ones. So what we do is that we get the input that we pre-process, as I showed earlier. Then we start from the root and we go downstairs. Whenever we get to any node, in the inner nodes, we try to match them. If we are confident that we are not going to find solution in the subtree of that node, then we prune that one and we do not go down through that one, and we look this way, and whenever we reach the leaves, we are confident that we have reached the leaves, so we are confident that it is going to give us a solution. Only what we have to do is that we have same type of same pattern of AST, and we just want to replace the variables, and we do that using the identification again. We have used a slightly modified identification for our purpose, and we just replace the variables that serve the same purpose. That's it. We have got the solution. This way we have we worked on 14 Java projects for training, and we used totally separate 7 projects to for our testing purpose. From that 7 projects, we collected 430 Java queries that were vulnerable, and we could find solution for 291 of them. And that is almost 68%. Of the 291, 229 were such that we could use them directly. Those were accurate, and other 58 were close, so they could be used with slightly tweaking here and there. Only 1.3% were irrelevant. Those could not be used. So basically we almost got solution got right almost 98% of the 291 solutions that we generated. For the PHP, we use 6 projects, and we used 4 projects for testing, and we worked on 151 vulnerable queries, of which we found solution for 130 of them, but this time only 62% of the 130 were acceptable because of the lower number of trainings dataset. Actually, if we could train on a bigger dataset, this results will obviously improve. Our approach is language agnostic. It has no style dependency, and we can ignore comments. There is more. This is learning based, and whenever we have more data, it will always become more accurate, and ours is still accurate and human readable than the rule-based solutions. And there are some limitations, such as ours are dependent on the Java SQL parser, and the SQL parser cannot work if there is query modifiers such as SQL calculation, found rows, or limit, and these sort of things. Only very little of them, and we cannot find solution if there were some errors code in the training set. That's why they also made some issues. And for batch query, there is actually no specific solution for batch query in prepared statement. That's why we could not work for batch query. That's all, and thank you so much for your valuable time.